let's take a look at marginal revenue. You remember marginal revenue means R prime of X. That's all it means, revenue prime, marginal revenue. The demand for a new computer game can be modeled by. Okay. So this is 27, what page? 217. So they give us P of X, lowercase p of X equals 53.5 minus 8 natural log X. And they're telling us that X is the number of games sold, somewhere between 0 and 800, and P is the price. Total revenue, R of X, is given by the price times the number of units we sell. So X multiplied by 53.5 minus 8 natural log X. Find the revenue. That's the first question. So part A. So revenue is the number of units times the price per unit. So I will distribute. So I have 53.5x minus 8x natural log x. So this is the answer. We didn't have to do anything, no calculus, just multiply x by p of x. Part B. Stop me if you have questions, please, anytime. Part B. Find the marginal revenue. Okay, so now we are ready to differentiate. R prime of X. Can anyone differentiate for us the first part? The first part.
53.5.
Of course, thank you very much. Minus 8. And now you have to open parentheses. Leave the negative 8 outside. And we have to differentiate this. Which formula or which rule will you apply on this? How is it called? Which rule? We have to be able to...
Product rule.
Of course. First function prime is 1 plus the first function. Can anyone differentiate natural log for us? Natural log prime is
1 over x.
Thank you very much. Which luckily goes away with this 1 and 1. Good. So 53.5. Now I distribute the negative 8 natural log x, and this is 1. Negative 8 times 1 is negative 8. Now 53.5 minus 8. That is 45.5 minus 8 natural log x. So the marginal revenue is this. Let me refresh your memory. This function gives the slope of the tangent line to the graph of R of x at any point where the function is differentiable. That's what we used in the previous example. Now let's see. It tells us how fast is this function changing, decreasing, increasing, I don't know. How fast is it changing? This is the original function. This one gives the rate of change of this one. It tells us for every point if this function is increasing, decreasing, if it's 0 and reaching, not 0, if it's reaching a maximum or a minimum or whatever. This function tells us a lot about the original one. Okay, so now let's see what else they want. How many units will be sold if the price that consumers are willing to pay is $40? So how many units And the price has nothing to do with calculus, because it's not a rate of change. It doesn't say what is the rate of change, la la la. It says if consumers are willing to pay $40, and that is P. P of X is the price. So if P of X, if lower P of X, P is 40, how many units will be sold? Which is X, which has nothing to do with calculus. So how do I address part C? If the price is $40, how many units are we going to sell? I will copy P of X here so you can see it. So how do we address this?
Can't you just plug in 40
Where? Yes, where?
into X?
X is the number of units
Oh.
between 0 and 800.
So then would you,
formula equal to 40?
Of course, this is the price. Very good. 53.5 minus 8 natural log X. What type of equation is this, and how do we think about it? Very important. Always important to identify the type of equation. So what type of equation is this? Please? Just read it out loud and you'll identify it correctly. What is it? What type of equation is it? Please, anybody?
logarithmic?
Yes, because that's what it has. So excellent. Let's clean it up. How do I clean it up? It's not ready for anything. It requires work. How do I clean this up?
Subtract 33.5.
Good, excellent. So then I have negative 13.5 equals negative 8 natural log X. Good. It's better, but it's still not cleaned up. What do I do now?
Divide by negative 8.
Very good. So I have natural log X equals 13.5 over 8. Excellent. Now I have to think in terms of the equivalency. This is a log equation. I have to change it into an exponential. How do we change this log equation into an exponential? I don't have enough room, so I'm going to move on to the next page. How do we change it into an exponential, please? This is the most important concept in this chapter.
Would you have it be e to the power
Of course.
13.5 over 8
Exactly.
equals x?
Yes. E to 13.5 over 8. And then we approximate x. Again, x is the number of units. Very good. That's the conversion. Base raised to this power equals x. Base raised to whatever equals x. Nobody can do that by hand, so let's share screen and let's take a look. Good. So E, and in parentheses 13.5 divided by 8 and close. Okay, so 5 let me just double check, was the in thousands. Okay. X the number of games sold in thousands. Okay, so then, so this is multiplied by 1,000. But there is some sort of oh, 800,000. Okay, got it. So it's not 0 to 800, it's 0 to 800,000. Okay, so now it makes sense. So at $40, everyone is happy with 5,400 and let's say 6. 5,406 units, games, whatever. Okay, good. Do you think we need another example, or we can move on?
Let's do one more.
Okay, perfect. So these problems, as you see, they have a lot of real-life applications. Natural log and exponential have a lot of applications in real-life situations. Good. As part of a study, students in a psychology class took a final exam and then took equivalent forms of the exam at monthly intervals thereafter. After T months, so that's 29, T is in months, okay? And the average score S of T, score, average score, as a percentage, okay? So the formula is S of T equals 78 minus 15 natural log of T plus 1 and 0 to 80. Again, 0 to 80 months. First question, what was the average score when the students initially took the test? Initially, originally, what does it mean?
T equals 0.
Yes, indeed, T equals 0. 0 plus 1 is 1. Natural log of 1 is always 0. Log in any base of 1 is 0. How do I know? A raised to 0 is 1. So log in any base applied to 1 is 0. You don't need to remember this, just plug it in the calculator. But 0 plus 1 is 1. Natural log of this is 1 is 0. 0 times negative 15 is 0 plus 78 is 78. So S of 0 is 78%. So when the course ended and they took the first exam, the average score was 78%. Part B. See, a natural log function models the score on tests. And all these are different applications. Heating water, warming such and such, population, all sorts. All of them have natural log in them. Multiple applications in real life situations. What was the average score after 4 months and after 24? Okay. B and C. So we have T, S of T. I'm going to put the 0 also in there. So they want 24, yes, 4 and 24. So at 0 we found 78%. And let's see what happens at 4 and 24. So this is no differentiation yet. This is just plain algebra. So I'm going to put it in the graphing calculator. 78 minus 15 natural log. Where is my natural log? Of T plus 1 do not do this by hand. Put the function in. So when you plug in 0, or we already know the answer, just in case you want to convince yourselves. And when we plug in 4, and then when we plug in 24. Okay, so 78, and then at 4 is 53.9. And then at 24 is 29.7. Good. Find now S prime of t. And then S prime of 4 and S prime of 24 and interpret. So, can anyone help with S prime of t? So here's the function. What is the derivative of this?
Zero.
Good. So then negative 15. Can anyone give us the derivative of natural log of t plus 1?
Is it 1 over t plus 1?
Indeed. Times the inner function prime, which is 1. Good. So this is the function, negative 15 over t plus 1. This is the rate of change of this function at any point where the function is differentiable. Good. I'm going to enter this function as well in the graphing calculator, and then evaluate it for 424, 0, doesn't matter, because we need those two. So in y equals, I'll create the second function as negative 15. Be very careful to put the denominator in parentheses, t plus 1. And then it's already in there. I already have all the answers. So at 4, S prime of 4 is negative 3, and S prime of 24 is negative 0.6. The measurement unit, percent per month. The rate of change has two measurement units, percent per month, percent per month. And now let's think about the interpretation. Initially, the score was 78%. 4 months later, it dropped to 53.9. At this moment, the score is decreasing by 3% per month. 24 months after the original exam that gave us an average of 78%, the average dropped from 78% to 29.7%. How fast is the score changing then? It's decreasing, but much slower. Not with 3% per month, but with 0.6% per month. Any questions on this?